Hello, this is Daegyo-ku from MIDAS IT. If you can hear me, please type yes in the chatting window. Okay, thank you. If you have a question, please use the window, and just type whether you want to ask something. Whenever you want to ask something, please use the chart here. Webinar will take about 1.5 hours. Okay, I will start webinar for today. Hi, I am Daegyo-ku from MIDAS IT. I am very glad to be here to introduce MIDAS Gen, window-based general-purpose structure analysis and optimal design system based on finite element analysis. MIDAS Gen is used in many different areas such as stadium, power plant, hangar, airport, tower, crane, and underground structure and such. Here is the contents for today's webinar. I will practice 3D two-way structure for those who are not familiar with MIDAS Gen and slab wall design with more advanced features. Then after Q&A, I will send you the email about the survey. In the survey, there are some questions. Also, in the last question of the survey, you can check on whether you want to get the certificate or not. Survey will be sent in 2 days after this webinar. And if you have a question, please ask me. Please type in the window. I will answer to you after I finish the second chapter, which is the auto mesh and slab wall design. Okay, let's start. The first chapter, the purpose is to learn basic feature with 3D two-bay structures. In the practice example, I will introduce entire step from the modeling to interpretation analysis result. This is the process of MIDAS Gen. I will follow this process as well for today. First, open the file and define the unit and axis, and assign the material and section, then modeling with the node and element, and assign the boundary condition and input the load. Then I will analysis and check the result and design. The structure shape and members used in this simple model are shown in this slide. We will consider following 4 load cases. Okay, open the MIDAS Gen and click New File here. I will introduce the framework first. This is the framework, and this framework follows the similar format as the window environment, where we have the main menu at the top, and icon menu here, main component and sub components, and work window in front of you, and message window where you can see the analysis results. And with the command message, you can call the menu directly. Workstream window on the left, which allows you to control go in and out the input data and design results. This is the test pane. Test pane display works procedure for advanced analysis function and description on input item so as to enable the user to work more easily. Also, user can import user-defined page for their own convenient menu. I will demonstrate this function in the slab design example. In MIDAS Gen, we also have the structure wizard function that users are able to auto-generate a number of elements. For instance, we have the wizard function for arch, beam, column, frame, and truss. We can also import-export the file Rabbit Tekla program and step, stat. Also possible to import-export the DXF file, AutoCAD DXF file. For more convenience, user can directly enter the model data through the MGT command shell function here. I will demonstrate it. Go to Tool and click the MGT command shell and search the function that you want to revise or input or delete. In my case, in this 3D two-bay, the wheel node Y direction is implemented. So I want to enter this force in the element 9. So go to command shell and beam node. You can just type and search easily and click the input data. And data was displayed in this command shell dialog box. And for the 9th element here, just click 9 and make run. And as you can see, the load is inputted in this simple way. Okay, let's start modeling. First of all, we need to set up the unit. Go to Tool and Unit System and define the unit, fit, and keeps. User also can use here in the status bar. And then change the coordinate. XY, XZ plane, click OK. And define the grid space 2 feet. You can see the front view here. Next, I will input the material and section property. In the Works View window, click right mouse button and go Property and click the material. Or user can use this worktree, click the Geometry, Property, and double click the material. Or user can also use the main menu or even the icon. Click Add to add the material. We have the database from many different countries, for instance, America, Europe, and many Asia. For the concrete, we have also many different code we provide for SRC. And uniquely, user can define their own material by input the property here. In this model, I will use the steel and America code. If you input the database, the steel property will automatically show in this follows. Click section. If you click the section tab, you can see the MIDAS Gen actually provide SRC, combined, tapered, and composite section. Where's the SRC? You can see many different SRC sections. And in the Value tab, user can define the section by input the section properties. Or we can import from the section property calculator. I will demonstrate it. Go to Tool and select the section property calculator. Define the unit. And define the grid size. Make your own section. And apply. In here, you can see the section property as well. And import it. Save it first. And go to Properties section. Click Add in Value. Click this Import for SPC. We can import the section, user-defined section here. Okay, I will define the section first. Click the code here and select the section size. This section is for column. Click apply. And also user can just type in this tab, so you can find more easily. This section is for beam. And when you click the show calculate result, you can see the area, shear area, torsional constant, second moment inertia, and such. Okay, click OK. Additionally, user can consider shear deformation or not with this checkbox. Okay, we finished to set up the material and the section property. Let's toggle on the node and element number here and create the beam and column. Right click in the work window and go to create element. Select the material and section. Input the beta angle for the column. And when you want to create the element, you should check the coordinate here at below. 12 feet high and 20 feet width, and I make 3 column here. If the minor axis of cross section is parallel to global x direction, we can change the beta angle to 0. If you change in the table, the beta angle also can change. Also, we have the function extrude element. We can extrude the element with the extrude element function. Go to extrude element, select the node here, and define the direction. Apply. Apply. You can generate. You can extrude the element in this way. Okay. Then create the beam to connect the column. When you input the beam here, beam will be automatically divided because the intersection is checked on here. Automatically divide here. Go to structure type and check on this icon, this box, to align the top of line element, and to consider panel zone effect. Click OK. Next, go to translate element, and coordinate should be global. And I will define the distance, select all, and apply. The element is copied, and then connect it with the beam. Okay. Click click, click. Next, I will input the sub-beam. We have the element snap function here for convenience, here at the bottom. If I assign it to, it automatically snap half point of the beam. And then click and click. Click and click. We have the function for undo and redo. We can revert the previous model stage using undo or redo the task cancelled by undo. With the shrink environment, we can verify the connection condition of the node and elements. For the sub-beam, we need to input the pin in each end by using beam end release function. Go to boundary in this tab here. Select the beam end release. Select the elements and click the pin to release the moment in both ends and apply it. Same as previous, to copy this sub-beam to here, go to the element tab and translate element and define the distance and check on the intersection and check on the copy element attribute. You can copy the boundary condition here and rows design parameter of the element, so you can save additional time for modeling. Click apply. Select the element first and click apply. In the display option, you can check whether the boundary condition is copied or not. The boundary condition, the pin is copied here. We can change the element parameters section. Material can be easily changed by drag and drop. First, go to change element parameter. This material section and thickness can be easily changed drag and drop function. And we have the element axis, local axis we can change, and element type we can easily change. In this case, I will change the beta angle for this element. Click 90 degree and apply. The beta angle is changed. Also, using a table, this element is number 11, so find number 11 element and using a table, just type 0 and the beta angle is applied again. Also, you can see in the worksheet your input data. And in my case, I will use the drag and drop function. All of this beam I will change to the column size. So just click the column and drag and drop it. And you can see the beam is changed to the column size. In MIDAS Gen, we provide those boundary conditions as follows. We can consider soil stiffness using a point spring support. In the type multilinear, we can consider the nonlinear property of the soil as well. And also we have the function for surface spring support. This function enables the user to specify the surface or line stiffness without having to concern about the mesh of element, which is automatically taken care of by the program. Okay, let's input the boundary condition. Click support here and use this select by plane. If you click one node in the model, it automatically selects all nodes in XY plane. And I will fix displacement and rotation and click apply. Also, selecting this support by direction, you can see different shape of boundary condition. I will explain about the hexagon here. This is the boundary condition. Half right describe the displacement, and half left is describe the rotational degree of freedom. X, Y, Z direction go through the clockwise for the displacement. Also for the rotation, X, Y, Z is go to clockwise. And if the Ry, in case of this, Ry is marked black, this means the rotation Y direction is released, and green color means it is fixed. So in this case, all of the rotation and displacement is fixed. Okay, now I will input the load case. Go to load and static load case, click this, and enter the load name, dead load, add, live load, click add, and WinNode X direction, add, and WinNode Y direction, click add. The load type is used to generate the load combination for design, so it is necessary to input exact data. Next, I will input the self-weight here toward the gravity direction. Click add. Next, using the assign flow load function, apply dead load and live load. Click assign flow load here. And in the load time, click this button and enter the flow load type. Live load, negative 0.05, keeps per feet square. And click add. And click add of the floor for the flow load. And you can see the input result if it is entered correctly. Next, I will input the WinNode X direction using the nodal load function. Go to load and click the nodal load. Select the WinNode X direction. Select each node here toward the X direction, 20 kips, and apply. For the load in Y direction, WinNode for Y direction, I will use the element beam load here. Select WinNode Y direction here. For the direction, we can input the beam load in terms of local axis of the element or global axis. In this case, this is the global Y direction, so direction should be global Y. And click 1. Then click apply. the wheel load Y direction is applied for this model. Additionally, I want to explain this model data text output. With this function, you can see all of the input data, load cases, material property, loads data, boundary condition, section property, and such. What you input, you can easily see in this text file. Okay, I finished to modeling and input the boundary and load. Then I will perform the analysis, save the file. Okay, analysis is done. To generate the load combination, click the result and click the combinations. You can see this window, dialog box. Users should generate the load combination in the Still Design tab to apply Still Design function. Similarly, Concrete Design tab for Concrete Design function. Also, SRC and Footing Design. Load combination generated in the General tab are not considered for the Design function. To generate the Still Design load combination, click this Auto Generate and select the code and click OK. Program automatically provide both positive and negative direction of wind load, so user do not need to define both direction. Let's toggle off the nodes element, number, and shrinkage. Next, from the result, I will check the reaction. Right-click and go to reaction. Reaction force moment, select it, and apply. Maximum reaction marked in the red color here. In the display option, user can change the color and text size and graphic scale. With the search reaction force moment, this function, we are able to see the reaction value acting on the node. If you click this node, the first result will be shown in this message window. Also, click the result table, reaction. If I select the dead load here, you can see the summation of the reaction here for the dead load. And user just can copy and paste it in the Excel. Also, using a graphic here, we provide various graphic and can plot the graphic, as you can see. Furthermore, we can check the load displacement from the deform shape function. Go to deformation here, deform shape. Click apply. And rear displacement. Go this tab, rear deformed here. Your displacement is also available to see the deformed shape in the middle of the elements here. We can see the displacements with contour. Also, force is shown in the contour as well. To explain about the symbol of the force in here, Fx is symbolized axial force, and Fy, Fz is the shear force y and z direction, and Mx is torsional moment, and My, Mz is bending moment x and z direction, z axis. So if I want to see the axial force, select the Fx and click apply. For the shear force y direction, select and apply. And for the bending moment, y-axis, select and apply. We also have the bending moment diagram here. In the first step, go to bending moment diagram. Here we can see the bending moment diagram. With the active, only this element. I will explain 5 points and exact. 5 points option display the member force calculated at every quarter point. And exact option display the member force calculate all along the length. You can see the difference. This is the quarter and exact option. Okay, and we can check the stress as well. Before go to PPT, I will explain about the stress. Okay. First, I will explain these symbols. SAX is axial stress, SSY, SSZ is shear stress, Y direction and Z direction. SBY and SBZ is bending stress due to MZ and My. You can see the formula in here on your right side. So in this case, I will check the combined stress at the bottom left corner here and click apply. I should activate, and yeah, you can see the combined stress at the bottom left. And maximum, you can also check the maximum here with the deformed shape. We have the function for render view. Also, user can walk through. With this function, we can see the stress and displacement in diverse angle. Also, Jen provide the video for the deformed shape here. Click, check on this animation and apply, and click this button, record. You can see how the model is deformed, and you can save this file to AVI. To check more detailed deformed shape and shear force diagram, bending moment diagram, and stress distribution on the cross section of the particular section, Go to Beam Detail Analysis, click it, and select the member that you want to see, and it will show the displacement and shear force diagram and bending moment diagram, Z direction and Y direction. And also you can see the stress variation in the cross section. Also, user can define the diagram to see the member force and stress of the beam elements, as well as the displacement, thrust member force, and stresses in same diagram. Click this user-defined diagram and define the diagram. In my case, I select 11 element. I want to see the axial force. Click the display option. You can select the color. In this case, I will use the red color and type the name and add. And for the same element, I want to see the bending moment y-axis. Select a different color and type the name and add. And go to the plot diagram, select both and apply. You can see here you can see the axial force and bending moment y-axis in a time. Actually, as I mentioned, this beam is the single beam. This beam should be a single beam, but divide into two elements. So with the member assign function, we need to specify these two elements as a single member to change this divides elements to single member. So go to design and general design parameter, click member assignment and select the divide member and click apply and select apply. And divide member is generated in a single member. I will explain the design in this time. Concrete building design and steel structure design are scheduled in March and April. I will treat the detailed design feature in that day, in March and April. So today, I will just show you the overall procedure of steel design in this webinar. First of all, go to the design and steel design parameter, design code, select the code, and perform the steel code checking. You can see the member, the first one got the NG, the column is NG, and the beam is OK. Also, in the steel design result, we are able to check the design result of the steel member by numerical component and contour. and easily can see the member ng by graphic. Let's change the member size to be a safe members. Go again, click the still code check again. First I will explain the graphic and detail. In the graphic report, you can see design information, member force, design parameter, and checking result for the axis bending combined and shear stress and such. And you can also save it. In the detail report as well. In detail report, we have the strength verification result in the form of detail calculation. For the selected member, you can see the detailed formula in this detail report. Okay, select the member again. This member required to change to the safe member. So click change and search satisfy section here and select one section and click the change and close. It's marked OK. However, still in this condition, this section is not implemented in analysis yet. So click update and click this section and reanalysis and recheck. In this case, change this section column is applied affect this beam. So in this case, I will change the beam again. Update, reanalysis, recheck. Okay, we got the OK sign for those two column and beam. Go to tool. I will explain the bill of material. Go to tool. We can check the member length and weight and density or even the qualities in this bill of material function. I will explain the mass data. There are three methods to input the mass data in MIDAS Gen. Firstly, go to model and select the structure type and check on this box here. By checking on this box, it will automatically convert the self-weight to mass. Secondly, we can convert the value of vertical component of the entered load to the mass. Go to model and mass. Select the load to mass function. So we can convert the value of vertical component of the entered load to the mass here. And we can enter the lumped mass data for the node directly. Go to mass again, nodal mass. Yes, we can input the data here, lumped mass data. In MIDAS Gen, for instance, in the beam, mass is lumped at end of the node here. Half-right mass of the beam is concentrated on the right end of the element. This red mark is red. The beam load is implied each end, and half left is same. The weight of the weight implemented in here. And next, I will explain the buckling mode shape. To explain it, I will open different model. If you see the worksheet, you can see all of the input data, and we input the actual force here and assign the boundary condition. Top is roller and bottom is pinned. To get the buckling load, go to Analysis and select the Buckling Analysis Control. In number of mode, I select 2 and click OK and perform the analysis. With the front view, go to the result and select the buckling mode shape. Check on the region and contour and apply. This is the first mode shape, and this is the second mode shape. Buckling load is calculated by multiplying the critical load factor here and applied load P. So buckling load, as I mentioned, apply load P multiply critical load factor, which displayed on your left window here. On your right here. Sorry. So in the FEM analysis, in case of the beam element, it calculates the deformation in the node, at the node. If you want to get more accurate and realistic buckling mode shape in the middle of the column, it is necessary to divide the column member into several elements. So in the first chapter, I introduced the basic feature with the modeling of the 3D two-base structure. Okay, I will start the second chapter, which is the auto mesh and slab wall design. The purpose of this chapter is to learn auto mesh and slab wall design feature. I will follow this step as follows. Once again, after this chapter, I get the Q&A session. So if you have any question, feel free to ask me after this chapter. And after this after 2 days, you will get the email about the survey. If you fill out the question, Uh, in the question, actually, we have the checking list for the certification. So if you want to get the certificate, just check on in the survey, please. And I will start the auto mesh and slab wall design. With this example, we will learn how to model the slab and wall with the plate elements. I will explain auto mesh function and slab and wall design. This model is 5-story building. As you can see here, consists with column, wall, and slab. I will apply Euro code for this building. Also, here we have 4 load cases: dead load, live load, and wind load. Okay, um, I already, because of time constraint, I already the model some part of this model. Okay, first let's define the unit in the status bar here, Newton to kilonewton, and here the mesh tab. Select the auto mesh planar area and select XY plane and select the area. Select the type about the mesh. Define the material and thickness and apply. As you can see, the mesh is automatically generated. Also, I will mesh the wall using the auto mesh function. Go to worktree and right click and activate only wall. And same, click the auto mesh planar area and planar element, select all, and select the material and thickness and apply it. Actually, there's a two approach for the modeling wall in MIDAS Gen. First one is using wall element, and the other one is using plate element. Wall element in this model is the plate element. Plate element often used to model wall for low-rise building, and it is possible to mesh horizontal and vertical direction. As you can see, for this model, wall element in Gen is often used to model shear wall for the medium or high-rise building. With the help of wall element, we can check the design force of the shear wall in the convenient way. However, there's a limitation that divide the wall element between the story is not allowed. Okay. Element connectivity between the slab and wall here is automatically considered by the program. Here the connectivity between the slab and wall, as you can see. Also, we can check the connectivity using or display free edge. Okay, let's input the dead load and live load using a pressure load. Right click, go to load and select the pressure load. First, I will input the dead load. Select the slab. And I will apply 2 kilonewton meter square. To imply the different for the live load in case. To imply the different amount of live load in the particular area, there's the two ways to do it. First, generate the temporary line element along the boundary of that area before meshing the slab. In this time, I will show how to do it. In this time, we suppose that here, this area is has a different magnitude of live load, so generate the temporary line element and mesh it for this area. So go back again and go to element, create element, and make a line element. And again, click the mesh, select XY plane, define the material and thickness and apply. And then user, go to load, pressure load, and select this specific area that you want to imply the live load. 3.5 kilonewton per meter square and apply it. As you can see, we can define this specific area. There's the other way to using the assign plane load function. Right click in the work window and go to load and select here the assign plane load. And load type, you can click this small button, type the name, and select the area. In my case, I will select, I will define the live load in the square, which is 5 meter and 3 meter height. So 5 meter length and 3 meter. And load is again 3.5, we suppose that, and click add. And define the direction. Here, and second point for the x-axis, and for the xy plane, y-axis, click, and then click apply. You can see the live load is assigned in this particular area. However, in this time, for convenience, I will apply the same amount of live load to whole floor. So again, go back to what we did here. The pressure, I only input the pressure load before, and then as same, I applied the same amount of live load in this whole floor. Go to load and click the pressure load. Select the load type, live load here. Click the select plane, XY plane, select it, and input the amount of the load, negative 8.5 kilonewton, kilonewton square. And apply. All of the input data you can see in the worktree. Boundary condition as well. Let's generate the 5-story building. Go to model and building. Click the building generation. Copy it, form wall, and 3-meter height, and click add. In this case, I will check off the copy node attribute, because if I check on, even the bound condition will be copied for whole story. And select all and apply. In this case, I on display pressure load, and as you can see, the building, 5-story building, is generated. And go to the story, building and story, to generate the story data. MIDAS Gen automatically generate the story data by click OK here. Automatically generate the story data. The reason why we need to generate the story data is, first, to auto-calculate the static, wind, and seismic loads, and secondly, to define the flow diaphragm. Lastly, to see the analysis result in each story, such as the story drift, story shear, and such. You can assign the diaphragm here, whether you consider or do not consider. You can assign here. Diaphragm should be assigned to apply the static wind and seismic load according to the selected codes. Let me open another model to which flow diaphragm is assigned. This is the flow diaphragm. As you can see, we can disconnect the particular area from the flow diaphragm using the diaphragm disconnection function. So in this case, I just select second floor. We assume that here is open space. So go to the boundary and select the diaphragm disconnect, this function, and select select the node, and click apply. You can see the diaphragm is disconnected. And go back to model. And go to model and building and control data. In here, you can see this box The static wind and seismic load are applicable to the flow for which flow diaphragm is not considered with the function of the static wind seismic load for the flexible floor. So you can check off or check on. In general static and dynamic analysis, we can consider P delta effect. Go to Analysis and select the P delta analysis control. Input the dead load and live load. Okay. Next, input the wind load. Go to Load and Lateral Load, Wind Load. Click Add. First, wind load X direction. Select the code. In this case, I will select the Euro code. And if you click this wind load profile, you can see the detailed information of the wind load. We provide pressure and additional and the story force, story shear, and such. Apply. Also Y direction. You can see the load profile as well. And click OK. Next, I will explain the different function. One of the different function. Go to Load and click the element beam load. In the load type, you can see the uniform pressure. For specifying the wind load on the opening structure like tower or plant, we provide beam load with the uniform pressure. This function recognizes automatically the exposed area of the structure members, so it obviates the need of calculating the wind load on individual elements. Next, I will input the earthquake load with the response spectrum. Go to Load and select the response spectrum analysis data and click the response spectrum function. Click Add and Design Spectrum. Select the code and click OK. Go again, response spectrum analysis data and response spectrum load case. First, X direction. Select the function code, and in this case I will consider accidental eccentricity here for each story. And click Add. For the Y direction, input the 90 degree. Same. We consider accidental eccentricity and click Add and close. Okay, we finished to modeling, meshing, and input the loads. Then perform the analysis. For this model, it takes some time, so I will open the model again, which already done for the analysis. Okay, all of the input data is same as previous. We have wind load and response spectrum for the earthquake load, dead load and live load with the pressure load. Okay. So let's check the distribution of the member force per unit length in plate element. You can check the plate force for firstly, go to the first and select the plate force moment here. Actually, you can check the plate first for the local and UCS user coordinate system. Let's check the element local axis first. Go to display. You can see the local axis. Let's check the bending moment about the local x-axis. Click MY, select local and click MY to see the bending moment about the local x-axis. And click apply. You can see the result. I will explain about the v-axis and vyy and myy and mxx. V-axis and vyy is the out of plane shear force, as you can see here, the direction, you can check it. And myy and mxx is the out of plane bending moment. You can check the direction here. This figure, this information is also in the online help, so you can check easily by clicking F1 in the MIDAS Gen program. And next, let's check the bending moment about the global axis. So I will turn off the local axis and select the UCS. The current UCS is the global coordinate system. So select the UCS and check MYY. First, I will check as I mentioned, the bending moment about the global x-axis. Select MYY and click apply. To check the plate force in the wall, we should change the UCS. For checking the wall here, the plate force for the wall, we should change the UCS, and let's check the MYY for the wall. Click this button, which is the select by plane. In my case, I will go here and select, change the user coordinate and select MYY and click apply. So we can check the MYY for the wall. To check the average of the plate force, check on the average node and apply. You can also check the plate force on the average node. We can see the internal force of the plate element along the cutting line. Go to force. Select the plate force moment again. And click the cutting diagram and specify the point and add and click the analysis. You can see the cutting diagram here. Uh, with the local direction force, we can check the resultant force on the selected plane. Resultant force and applied to the centroid of the selected plane are calculated on the base on all node force in the selected plane. So go to result and select the local direction force sum here. And select the point. And click calculate. You can check the resultant axis, axial force here, and the shear force, Fy, Fz, and torsion, and bending moment, My, Mz, torsion here, bending moment, My, Mz axis for this closed section. Let's check the vibration mode shape. Click the result and go to the vibration mode shape. And I will check the first mode. Click apply. This is the first mode for the vibration mode shape. And you can see the second mode. Also, click this button. You can see it in this table. We can check the period and frequency and modal participation for each mode. We also are able to check the story drift. Go to result and result table. Go to story and click the story drift here. This story drift due to the static and dynamic load will be displayed in the table. Okay. Then auto-generate the load combination. Go to result and combinations and select the concrete design. Click the auto generation and select the code. Click OK. The load combination is automatically generated. And go to, for design, go to concrete design parameter, design code, and select the code. Because of time constraint, I will design only some part of the element here. Go to design and concrete code design. Click the beam design or column design, or you can use for the convenience, go to select the perform batch design and click both beam and column design and run. In the result, you can see the graphic report. We can see the design result in summary of calculation for the selected member. You can see the rebar, the spacing and number, and the checking ratio for the bending moment and shear. Also, you can see the detailed report as I mentioned. the automatic design result in the detailed calculation for the selected member. You can see all the formula. Other thing is same for the column design, but in the column design you can see the PM 3D PM interaction diagram applicable for the factored axial force and biaxial moment. Additionally, in the works tree, you can change the rebar data. Right click and select the property. You can change the rebar data, diameter, and number of lever. Here at the bottom, you can change. For the low, you can also add the rebar and change the diameter. For the slab design, next I will do the slab design. For the slab design, as I mentioned in the beginning, I will use the user-defined menu for the convenience. So go to the task pane and select the task pane here and import user-defined page. I will select this file, and what I defined for the menu is displayed in MIDAS Gen on your task pane. This format is very easy to make. You can use the notepad, and as you can see, just write the page and design and group task and each name and the path. Each path just simply entered and save it and import in the user-defined page. So I will select the load combination first for the slab wall element design. Because of time, to save the time, I'm going to select just one load combination, and I'll only activate the third stories. And let's define the control parameter of the stress crack deflection for the serviceability check. Click this serviceability parameter and select all and apply. And next, slab flexible design. We can check the flexible flexural design result for the slab element in contour. Click apply. You can check the flexural design result for the slab element in contour as in this picture. Also, you can see the result in the report. You can save it. Also, you can see easily in the table. You can also copy and paste in the Excel file. Next, also we can check the punching shear at the support of the slab element or at the concentrated loads. So apply. You can check the punching shear. And also can see the result in the report. Next, I will do the serviceability checking. In the serviceability checking, you can check the stress checking for the concrete and reinforcement and crack control, crack width, minimum rebar space, and rebar spacing, rebar area, and rebar diameter, and deflection, uncracked and cracked. In this time, I will just check the uncracked for this deflection. Go to design and perform the crack section analysis. Again, I will, because of time constraint, I will just change the iteration, number of iteration, and do it again to save the time. And then click apply to check the uncracked deflection. And you can also see in the report. And can save it as well. We are capable to design the wall as well. Click the resistance ratio here and can see the wall design result here. You can see in the report or in the table. Okay, I finished for the auto mesh and slab wall design. Next is Q&A session. If you have any question, feel free to ask me. I will ask you as well as kindly as possible. Okay. I will announce one more before I go to the Q&A session. Actually, we do not, today webinar, we do not provide the video record of this webinar because we need to provide certificate to the participants only. So after 2 days, you will get the survey, and in the survey you can see the certificate. You can just check on whether if you want to get the certificate, just check on, and if you ask the record, then yeah, we can take it. And in next webinar, the topic is reinforced concrete building design, and the date is 3rd week of the March. Okay, I will answer for your questions. For the question, Muhammad, you asked me the gen capable of the optimize of steel and concrete structure. Yes, it is possible to optimize the steel and concrete structure. This session, I will explain more detail in the next month, 3rd week of the March. Guri, Guri asked me, can I design the foundation by EC in MIDAS Gen? Yes, you can do the mat foundation in MIDAS Gen. Mr. Chao Hashin, for your question, you ask what the difference with the selection of include sub-beam in the flow load type. We can consider the weight of sub-beam without including in the model in the modeling. Yes, Mr. Kader, you ask, can wind and seismic load be automatically created by the program? Yes, wind and seismic load can be automatically created in the MIDAS Gen. Taiha, Mr. Taiha Younes, you ask, is there any available tutorial video on the website? Yes, we provide the tutorial video and many tutorials on the Moose website. The address is www.midas, MIDAS, user, user.com. Once again, www.midasuser.com. You can access and you can easily find the tutorials. You also can download the trial version, demo version in our website, Moose website. So just access www.midasuser.com. Thank you. Mr. Reynaldo A., you ask, how do we model building with base isolators? Can Midas handle the design? Yes, Midas Gen can handle the base isolator for the building. I will demonstrate this function with more greater detail in May, which is another training session. So I will announce it by the mail. Okay. 미켈, 미스터 구루치가, Mr. 미켈 구루치가 asked me, could you repeat what did you explain about the difference between plates and walls? Actually, there's a two approach for the modeling wall in MIDAS Gen. As I mentioned, first one is using the wall element, the other one is using a plate element. And the plate element is often used to model wall for low-rise building, lower than 10 stories. And it is possible to mesh the horizontal and vertical direction. Wall element in Gen is possible, and the wall element is used high-rise building or medium-rise building. With the help of the wall element, we can check the design force of the shear wall. Mr. Alozia Okezia, you ask, is it available to use different code in designing different part of the same structure? For instance, yes, in MIDAS Gen, it is possible to use the different code to check the model and design and to perform the analysis. Yeah, it is possible to use the different codes. You can design the both American code and Europe code in the same model. Mr. Rex Andres, you ask, is it capable also to consider shear wall design with a large opening? Yes, you should use the plate elements to design the shear wall with large opening, so it is possible. Because of the time constraint, I will answer your question, 10 more minutes. So there's a lot of question. If you want to ask, just send the email to issupport@midasit.com. So I will type. Yes, issupport midasit.com, and 10 more minutes I will answer the questions. Mr. Johar asked me, what about connection with different program? We can import and export the Revit and Tekra structure, and also can import and export the AutoCAD DXF file. There's other questions about the certificate. I will mention again, after 2 days, you will receive the survey email, and in the end of the survey, you can check whether you want to get the certificate or not, and we will send the certificate to you. So after 2 days, please check the email again. Thank you. Mr. Mikhail asked me, could you explain again what you explained about the test pane and slab design? So in the slab design, I import the user-defined page here in the test pane. Click import user-defined page and select what I already generate, and you can make your own menu in the test pane. The way to generate the documents, the file here, the importing file, is very easy. Just open the notepad and type with this format, just name and the path to go there. design, mesh slab wall design, slab wall load combination. This is the path in each main menu. Just type it in the notepad and save it, and you can import it. Use the user-defined page, import user-defined page, this function. Mr. Lex Andres, your question is there any option to select dynamic analysis type between the eigenvector and Lex vector? Yes, we have. Here you can see the eigenvector and Lex vector. Mr. Songhua Han Songhua, you ask in MIDAS what method of modal combination is used for response spectrum analysis. We have the SRS, CQC, and ABS and linear. I will show it. Here you can see we have the modal combination type SRS, CQC, ABS, and linear. Uh, Mr. Vincent Tang asked me regarding the wall, can we do summation of force for more than one wall? For example, all the walls, cores on the floor plane. In MIDAS Gen, yes, you can get the summation of the force for more than one wall. The way to do it is assign same wall ID and then you can see the summation of the force. Um, Time is done. Actually, I'm sorry about that, and thank you for your questions and participation. If you have the question and what I didn't answer to you, you just send the email esupport@midasit.com. I will type it in here again. Yes. As you can see, esupport@midasit.com. esupport@midasit.com. Send your question and we will kindly answer to you. And thank you for your participation for today, the education webinar. And the next webinar, as I announced, the topic is reinforced concrete building design, and it will held in third week of the March. Thank you so much, and have a good day.